Hello, welcome back. In this session we just want to talk about the main loop of GA, and in addition to that we have to talk about the main one of the main operators in the GA. It is crossover. So let's just get started. We just go to our code here. So we just define our main loop here. For IT would be 1 to max it. So remember that we have defined maximum iteration here in our parameters, which is the number of iteration here. So it would be our main loop here, and we would use two operators here. The first one is crossover and the second one is mutation. So first of all, we just take a look at the crossover and see what we can do for applying these operators in this loop. So before going further, we just wanted to give you an explanation about the crossover. In general, we have many different types of crossover, and in this session we just want to talk about the single point crossover. We have also double point crossover and uniform crossover. So for simplicity, we just apply in this session we just apply the single point crossover, and then for the other session we just want to talk about the other kinds of crossover. So in single point crossover we have a two parents, parents 1 and parents 2. Suppose that we have a parents 1 such as like this, and we have also parents 2 such as this. So we have to determine the cut point, and this cut point would be randomly selected from one of these variable to n bar minus 1, because if we just selected the last position, we cannot to use the cut point because we just wanted to divide any parents to two parts. So we have to select one of these points here. So suppose that our cut point would be number 6. So this line, it's our cut point, and we just wanted to generate two childs or offspring, and child 1 would be something like that. So for child 1, the first part just is grasped from the first part of parent 1. So this is the first part of parent 1. The second part of child 1 would be second part of parent 2, and this would be happen for the child 2 in vice versa. So the first part of child 2 would be the first part of parent 2, and the second part of child 2 would be the second part of child 1. Before going further, we just let you know that we have two ways of storing offspring for the crossovers. So one of these ways to store offspring would be in one column, and another way to store the column would be in two separated columns. So this way would be more effective because we just easily can compare this offspring with together. So we just wanted to use this structure to our code. So we have to define two columns and try to put this and store this offspring in two columns. So let's just go to our code and see what we can do. So we have to define our loop for crossover. Just before going further, we have to just mention you we just define NC with this formula, so it would be even, and we just easily divide it to the 2 because we have wanted to save in two different columns. So for I, NC divided 2, we have this column here, and before going further we have to just determine the population of the crossover. So we defined pop C as pop for crossover here, that this is rep math, and we just copy this structure to the rep math with NC 2 and 2, we wanted to just store this crossover to the two columns, so we just divided the number of crossover divided to 2 and in 2 columns. So we have to apply this loop to this pop C. So first of all, we have to select 2 pops from our population, and this is I1 and this is I2. I1 will be rand I, which is selected between 1 and a pop, and this would be happen for the second index. So these 2 indexes are just selected for our crossover, so we have to define our crossover function. So let's just save it and use edit. So we have a function here with 2 outputs, y1 and y2, and y1 and y2 would be our crossover, and we have a single point crossover here. And we have 2 inputs, x1 and x2. So first of all, we have to determine the number of variables, so we can use the num_el for x1 or x2. So n would be num_el x1. This is of number of variables, and we have to select randomly an integer value with it between 1 and n-1. So C, our cut point, would be something like that, n-1, and then you have a y1 and y2. As you remember, that's for y1 we have a x1, which is from the first index to C, and then we have also x2 from C plus 1 to the end, and this would be happen for the second of a string. So here x1 and x2 just change to each other. So let's just add some comments here. So let's just save it. This is our single point crossover, and let's just apply this code here. So here we have a pop CI one dot position. We have a y1 and y2 for x1 and x2. Here we have a y1 and y2. What is y1 and y2? Y1 and y2 actually will be pop C I1 dot position and y2 will be pop I2 here just for the second column, that position, and x1 would be pop the first selected index, pop I1, that position, and this is would be pop I2. So let's just here, and I think it's better idea to add some comment here. So let's just save it and see what's happened to our code. I think it would be better. So here we have just select this point, just starting our loop. Here we have to just define the POPC as a population for crossover. So here we have a NC, and NC divided 2 would be 6. So the first index I1 is selected, this is a 9, and second index just selected, and here we are just go to the single point crossover. So here would be our first input, and here is just our second input, and this is a n would be equal 10 number of variable, and we just determine the cut point here, and 6 would be selected. So y1 would be something like that, and this is applied for the y2. So just go to our code, and you can see that the pop I1 dot position and pop C I1 dot position and pop C I2 dot position is just obtained from these two pop. So we have to evaluate them. So we can use the following code. So we just evaluate the first offspring, and this is would be for second offspring, and add some comment here. So let's just save it and see what we can do. It's okay. So as you can see, that this is our first offspring, and the construction is just evaluated, and this is the second offspring. So let's just go further. So the second offspring is just evaluated, and I think that it's enough for this session. Let's just go to the next step.